Okay, everyone. I know you probably hate to hear this, but this is the last section, the last of the new material for this semester. So, sketching polar equations. Sketching polar equations. So, basically, what we're going to do is we're going to sketch these things using a point by point system, kind of like you do with an X, Y, T chart in the rectangular coordinate system. The only difference is we'll have a theta and r instead of an x and a y. The most basic graph of a rectangular system is x equals a or y equals b. As it says, these are our horizontal and vertical lines. The same can be said for polar systems. R equals a or theta equals b. Now, what kind of graph is r equals a? What kind of graph is r equals a? Well, think about that. Think about our polar system. You got all this, with our polar system. Um, r is the distance right here. So if r is consistent there, then it's going to be the same distance no matter what the angle is. So no matter where you go around this circle, around our spiral there of our polar coordinate system, r is going to be the same difference. So what this ends up making is a circle graph. Okay, a circle graph. Now on the other hand, theta equals b. If your theta, let's say, is pi over 4, well, this would give you a theta of pi over 4, but so would this. Remember, the difference in these two is here r is positive, here r is negative, but that's still pi over 4 if you remember. So what theta equals b is a straight line, a slanted straight line. Okay, a straight line. All right, so here's one of our basic graphs. It's called Archimedes spiral, and this is the one we're going to take a look at first. So what I would do if I were you is I would pause the video right here, and I would go to the internet, print me off some polar coordinate graph paper so that you don't have to draw all these spirals. Okay, that, or you can go to Office Max. They probably have it somewhere like that. But this is our polar graph, of course. The example we're going to be using is r equals 2 theta, and we're going to do it where theta is from 0 to 5 pi over 3. 5 pi over 3. Okay? So, draw yourself the T-chart, just like you would if you were doing a rectangular system. The only difference is we have theta and r. So I'm going to start with 0, and what I'm going to do is I'm going to just use unit circle angles. Okay? Throughout all of this, the ways I'm going to show you to do it will mostly use unit circle angles, which is going to pay off for you because you know what a lot of those angles already are. It should make the calculations just a little bit easier for you, and so on. So 4 pi over 3, 3 pi over 2, 5 pi over 3, and we can stop. Now, so what we need to do is take our 0, plug it in, we get 0, plug it in for r, plug it in for theta here, and that'll give us r. Now, go ahead and get the decimal answer. You don't want the pi answer in this because remember we are using, this is going to be our r, so this is a distance, this is not an angle. So when I plug pi over 6 in for pi, I get 2 pi over 6, so I get 2 pi over 6, which is pi over 3. So pi divided by 3, punch that in your calculator, and you should get 1.05. Okay? Do 2 pi over 3. 2 times pi over 3. We get the 2 from right here, remember. So 2 times pi over 3. And plug that in your calculator. 2.09. We do 2 times pi over 2. Well, that's just pi. So that's 3.14. And continue to plug in and figure out what the decimal answer is, okay? And so that's going to give us 4.19. That will give us 5.24. Pi would just simply give us 6.28. When we multiply it by 2, 7 pi over 6 is 7.33. 4 pi over 3 is 8.38. 3 pi over 2 is 9.42 as you plug it in to our equation above. And then the last one gives us 10.47. Now let's assume that each of these lines here represents 2. So that's 2, 4, 6, 8, 10. That way we have enough lines to get our R's down here. Alright, so 0, 0. Well, of course, that's going to be in the middle there. 0, 0. We have pi over 6, 1.05. So pi over 6 is right here. 1.05 is somewhere right in there. We have pi over 3, 2.09. Pi over 3, and then 2.09, which is going to be somewhere right in here. Then you have pi over 2, 3.14. So this would be 2, and so 3.14 is probably right in here. Then we have 2 pi over 3, 4.19. So that's going to be somewhere right there. Then you have 5 pi over 6, which is 5.24. So that's 2, 4, 5.24, somewhere right in there. And then you have pi, 6.28. So 2, 4, 6.28. And then we have 7 pi over 6, and that's going to be 7.33. So find 7 pi over 6, and that's going to be 7.33. So 2, 4, 6, 7.33. And then that's going to be 4 pi over 3, 8.38. So that's going to be somewhere right in here. And then that's going to be 3 pi over 2, 9.42. And then we have 5 pi over 3, 10.47. Somewhere right in there. Now, this is polar. We go in circles, okay, in a circular form. So, our graph looks something like this. So, it's almost spiraling out. That's why it's called Archimedes spiral, okay? So you can see a better picture of it in your book, but that is basically how you would graph it by hand. It doesn't have to be perfect. It's going to be hard for you to draw that perfectly because it's a spiral. Okay? So let's look at another example. Let's look at R equals 4 cosine theta in degrees. Okay? R equals 4 cosine theta in degrees. Alright, so let's go ahead and draw our t-chart. So there's our theta and our R. 0, 30, 60, 90. Now, notice this doesn't give us an end. It doesn't give us an interval. We don't have an interval over here like we did in the first problem. So that means we have to keep going to infinity. And you're thinking to yourself, oh my goodness, Mr. Francis, why are you making us go to infinity? Well, what you will notice is after you get through 210, once you go through 210, this graph starts repeating, okay? So really you're not having to go to infinity, because after this, after 210 degrees here, the graph repeats. The graph repeats. Okay? So you can really just stop it there once you repeat. So a good rule of thumb is if it's not giving you an interval, it's probably repeating somehow, some way, because obviously we can't expect you to graph something to infinity. Okay, so keep that in mind. So take 0 and plug it in, and you get 4. Take 30 degrees and plug it in and solve. You get 3.46. Make sure you're getting the decimal answers. Take 60, plug it in for theta, and solve. Make sure your calculator here is in degree form, because in the last problem it was in radians. Take 90 degrees and plug it in. Take 120 and plug it in, that's -2. Take 150 and plug it in. 180 and 210. And you end up beginning to repeat itself, okay? So at this point, you don't have to go any further. Now, you would recognize that after you went a little further. I recommend going a little further this time. I'm not going to in this video because of time of a video, but I recommend you doing 225 next, and seeing what it ends up, and seeing so you can see the repeating, okay? Gives you an opportunity to see something like that. So remember, this is 0 degrees, 4. Well, that's going to be right there. We have 30 degrees, 3.46. So 1, 2, 3.46 is somewhere right in here. 60 degrees, 2. 60 degrees, 1, 2. We have 90 degrees, 0. Now notice we've made a semicircle now. Watch what's about to happen. 120, which is here, this is positive 120 up here. Or this is where the R is positive, right in here. So since R is negative, we're going to go back this way 2 units. Okay? 150. 150, it's positive on this end. So negative 3.46 is we're going to go back this way 1, 2, 3.46, somewhere in there. Now I'm probably going to be off just a little bit. Yes, because 3.46 is actually right there. Don't look at that one. All right, so 180, -4. Well, this is positive 180 over here. -4 would be back right here where we started. So see, we're starting to repeat. 210, positive here. -3.46 would be back where we started here. So see, we're starting to repeat the dots. So if we continued, our pattern would just repeat in this same circular pattern, and that's what happens. We get a circle out of this. Okay? Hopefully this is going to be pretty easy for you to graph. I hope it is, folks. I hope this really makes sense to you. Remember, this part right here will not be tested on your exam, which is a good thing. You will be tested on it in a quiz form in class, but this is part of the preparational material for calculus. So this is we're right now we're in preparation for calculus is what this is, okay? All right, so let's look at another problem. Rapid sketching. Now, you may think what we've done is rapid, and it was pretty much, but there's even ways for us to do it a little more quickly if we just look at instances where sine and cosine are 0 and 1, okay, which would be our quadrantal angles, okay? So if you're looking at this in radians, okay, so what I'm going to do first is notice this is this is one of our to infinity and beyond looking graphs, because we have no interval here. So what we need to do is this is why we call it rapid sketching. I'm just going to look at the quadrantal angles. Okay? Just going to look at my quadrantal angles. Now, hopefully this is going to repeat, and you'll be able to just stop at 2 pi, and we won't have to go any further. Okay? So we'll notice that here in just a minute. Well, so if I plug 0 in here, if I plug 0 in for our theta, I'm going to get 10 for my answer for r. If I plug pi over 2 in for my theta, I'm going to get 5 for my answer for r. Okay? When I plug pi in for my theta, when I plug pi in, I get 0. When I plug 3 pi over 2 in, 3 pi over 2 in gives me 5. And 2 pi in gives me 10. So yes, we're repeating now. So, and you can see the pattern that we have going here. So we're not going to have to go any further than this. So let's look at how we can benefit from this rapid sketching. Notice we're not doing every angle, okay, of the unit circle. Now, if you want to, you can do the angles of the unit circle. I am more than happy for you to do that and to do the point by point. I'm not going to tell you which one to do. The directions may say rapid sketching, but by all means, you can use point by point if you understand it better. I use point by point a lot more than rapid sketching, just because I like 6, 8, 10. I like having more detail to my graphs, but that's me. But here's a way to rapidly sketch it. All right, 0 degrees, 10 is out here. All right, pi over 2, 5. So 2, 4, 5. All right. And then what we have here is we have pi 0, which is going to be right here in the middle. We're going to have 3 pi over 2 and 5, so 2, 4, 5. And we are going to have 2 pi 10. So we're back where we started. So yes, it's repeating. Now, what you need to notice is that theta, as we go from 0, because this is 0, as we go from 0 to pi over 2, theta is increasing. Okay? As we go from pi over 2 to 0, theta is decreasing. 0 to 3 pi over 2, it's decreasing some more. Okay? Excuse me. Pi over 2 to pi, it's decreasing. Pi over 2 to pi is decreasing. And if you go from pi to 3 pi over 2, pi to 3 pi over 2, is what we would say. We would actually say that it's increasing. Now, you're thinking to yourself, Mr. Francis, we're going down. How is that increasing? You can't think of this like the rectangular coordinate system. Remember, this r value is 0. This one is 5. So we are increasing. See? We decrease from here, 0 to pi over 2. We decrease from pi over 2 to pi. We increase from 0 to 3 pi over 2. And we from pi to 3 pi over 2, and we increase again from 3 pi over 2 to 2 pi over to 2 pi. So where people get this confused is thinking of it in terms of the coordinate plane system. So don't do that. Now, if you notice from our last sketch, we go around in circles when we draw these. So when you go around in the circle, it's going to look something like this. And then we got to go around again to here. We're going to go around, and we go around again. Now, what does that look like? Hopefully you say, well, Mr. Francis, it looks like a heart. And that is why this is called a cardioid. I misspelled it. A cardioid. Okay? So, it will look like a heart. Okay? It will look like a heart. Now, this is a sketch. It's not going to look exactly perfect like the one in your book. The one in your book is computer-aided drawing, so it's going to look perfect. It just needs to have that general shape, okay? We're not calling for any artistic masterpieces here. So just that general shape. So let's look at another one. Let's look at r equals 2 sine theta. R equals 2 sine theta. Okay, so, or sine 2 theta, excuse me. Theta is in radians, notice. Alright, so, now, here's what I want you to notice when I make my T-chart. Our T-chart is now going to have 3 columns. Because we no longer just have theta as the angle, it's 2 theta. So what I need to find out is where 2 theta equals these. Where does 2 theta equal our quadrantal angles? Okay? And since this is twice theta, instead of going to 2 pi, we'll need to go to 4 pi. So 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Does that make sense? It's twice theta, so we have to go to 4 pi instead of 2 pi. Now, if I'm wanting to figure out what theta is, just divide by 2. So that's going to be 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi to find theta. Now that's why we had to go to 4 pi. Notice we ended up, for theta, we ended up with 2 pi, just like we normally do, but because it's 2 theta, we have to end up at 2 pi. Now, we can find r. So the sine of 0, because we know what 2 theta is, so we don't have to do any multiplication here. So the sine of 0, that should give us 0. So the sine of pi over 2, and that's going to give us 6 when you punch all that out. Now you're not going to have to multiply times 2 here. You're just going to have to take the sine of these, because we've already figured out what 2 theta is. So you don't have to worry about 2 theta anymore. You can just take the sine and multiply by 6. So that's going to give us 6. So pi is the sine of pi is going to give us 0 again. 3 pi over 2 is going to be negative 6. 2 pi is going to be 0. 5 pi over 2 is going to be 6. 3 pi is going to be 0. And hopefully you can see the pattern and you can fill in the last ones very easily. Now, let's go ahead and plot our points. So what we have here, we have 0, 0. We have, now, when you're getting ready to plot your points, we're not this graph here doesn't contain 2 theta. This graph contains theta. So we use polar coordinates are made up of theta and r, not 2 theta and r, okay? So you have to use this column. That's why we found it. You have to use this column when you're graphing. So 0, 0. Pi over 4, 6. So 2, 4, 6. We have pi over 2, 0. We have 3 3 pi over 4, negative 6. So 3 pi over 4 would be positive in this direction, so negative 2, 4, 6 would be over here. Okay, so pi 0, back at 0 again. And we go from this point, 5 pi over 4, 6. So 5 pi over 4 is down here. 2, 4, 6, it's going to be positive, so it's still going to be down here. 3 pi over 2, 0, that's back right there. 7 pi over 2, or excuse me, 7 pi over 4, and then we go back to negative 6, so that's going to be 2, 4, 6. Now I want you to notice what we're doing here. From 0 to pi over 4, we're increasing. 0 to pi over 4, we're increasing. Pi over 4 to pi over 2, we're decreasing. Pi over 2 to 3 pi over 4, we're decreasing. Pi over 2 to 3 pi over 4, we're decreasing. This is still 3 pi over 4. Don't look at that 7 pi over 4 and think that. Remember, it's 3 pi over 4, negative 6. So it's still 3 pi over 4. From 3 pi over 4 to pi, we're increasing back to 0. From pi to pi over 4, we're increasing to 6. From pi to 5 pi over 4, we're increasing to 6. We're decreasing again, back to 3 pi over 2. We're decreasing again from 0 to negative 6, from 3 pi over 2 to 7 pi over 4. Decreasing again. And from 7 pi over 4 to 2 pi, we're increasing. And I think I just drew the wrong ones. I'm sorry about that. Just follow your pattern like I did there, and you should come out with a figure like this. Looks almost like a flower petal. What I should have done, where I messed up, if you noticed, was when I was reading these, I drew it the wrong direction. Where I should have drawn this direction first, I drew this direction first. It really doesn't matter. Once you see the pattern, it's not going to matter which direction you draw first because the pattern is repeating. So it's going to be the same no matter what direction we go. Does that make sense? So forgive me for the mistake there. There's a good example of this in your book. So let me go over it one more time. Okay? Just for sake of making sure you know. From 0 to pi over 4, we're increasing. From pi over 4 to pi over 2, which is right here, we're decreasing. So that's where that connect's made. From pi over 2 to 3 pi over 4, we're decreasing. So from pi over 2 to 3 pi over 4, we're decreasing. Now remember, 3 pi over 4 is this one right here. Okay, it looks like 7 pi over 4, but it's 3 pi over 4 negative 6. From 3 pi over 4 to pi, we're increasing back to 0 again, which is how we get that connect. Okay, from pi, which is in the middle, to 5 pi over 4, we're increasing. This is where I made the mistake a moment ago. So let me not make it again. From pi to 5 pi over 4, we're increasing. There we go. From 5 pi over 4 back to 3 pi over 2, we're decreasing. And then from 3 pi over 2 to 7 pi over 4, we are decreasing. Now that's going this direction. Decreasing with 7 pi over 4 is where we go back this direction. I know that can get confusing, so be careful. And from 7 pi over 4 to 2 pi, which is back in the middle, we're going back to 0. All right. corrected that little error. There we go. Okay, so hopefully you understand that now. You see how to read that and use the increasing, decreasing to draw. Okay, that's going to be very helpful in helping you sketch these very quickly. Now, the great thing about these graphs is they're going to be picturesque kind of graphs. They're going to look really neat when you graph them. And you may even want to try to set your calculator in polar form. You can even set it in polar coordinate form and try graph it on the calculator and see what it looks like. But be able to sketch those with a T-chart, rapid sketch like we did just there. Now, on page 438 in your book, what you will notice is there's a table of polar curves. Make sure you look over those because you should be able to, if you memorize that table, you should be able to look at any of these curves that you're given, these basic ones, and tell me kind of what the graph is going to look like. You can tell me if it's a cardioid or if it's a four-leaf rose or whatever. Okay, so look over those. If you have questions, please let me know.